Hello, this is Ray, one of the program presenters in the Atchison Planetarium at Cranbrook Institute of Science, with a look at the pre-dawn sky for the week of May 10th. Starting on the 10th, the planets Jupiter, Saturn, and Mars are spread out across the sky from the southeast to the south-southeast. Jupiter is brightest in the south-southeast, Saturn is to the left of Jupiter, and Mars is farther to the left in the southeast. This configuration will remain about the same for the next couple of months. The noticeable difference will be Mars putting more distance between it and Saturn. On the 10th, the waning Gibbous moon is located in the constellation of Sagittarius, near the location of the center of our Milky Way galaxy that was mentioned last week. On the 12th, the moon is below Jupiter, and Saturn is to the left in the south-southeast. On the 14th, the moon will be to the right of Mars in the southeast, and on the following morning, it will be below Mars. There will be an excellent opportunity to spot the International Space Station on the morning of the 14th, weather permitting. Here in southeast Michigan, the ISS will rise in the northwest and appear about 10 degrees above the horizon at 4:53 a.m. Eastern Daylight Time. A good way to estimate 10 degrees is to hold your hand at arm's length with the back facing you and make a fist. The distance from one side of your fist to the other is about 10 degrees. 3 minutes later, the ISS will be near where the handle of the Big Dipper connects to the bowl. The ISS will pass through the bowl of the Little Dipper at 4:56 and be at its highest in the north-northeast, 57 degrees above the horizon a minute later. From this point, it'll get lower in the sky. At 4:58, it'll be at the upper right of the great square of Pegasus in the east. It'll disappear after 5 o'clock when it's about 11 degrees above the east-southeast horizon. The ISS is the third brightest object in the sky, and visible to the naked eye. It'll look like an airplane moving very fast from the northeast to the east-southeast this time around. Face south in the morning this week and look nearly overhead to locate the bright star Vega. Go about 23 degrees to the upper left and you'll see another bright star. This is Deneb in Cygnus the Swan. A way to approximate this distance is to hold your hand at arm's length again and spread your fingers. The distance from the tip of your little finger to the tip of your thumb is about 20 degrees. Deneb is located at the top of an asterism called the Northern Cross. Below and to the right is a star where the cross arms are attached. Continuing in the same direction, we pass Eta Cygni and finally come to Albireo at the foot of the cross and the beak of Cygnus. Albireo is about 15 degrees to the lower left of Vega. Albireo's distance from Earth is estimated to be 380 to 430 light years. If we consider the greater of the two distances, the light we see tonight left the star around 1590, which was shortly after the Spanish Armada was defeated by the English. Albireo looks like a single star, but it's one of the finest double stars in the sky. It's estimated that the universe contains more multiple star systems than single stars like our solar system. We could have been in a double star system ourselves if Jupiter had been 80 times more massive when it formed. Jupiter is mostly hydrogen, like most normal stars, but it wasn't massive enough to initiate thermonuclear reactions in its core and fuse hydrogen into helium. Had Jupiter been a star, it would have been a small red dwarf. It would have appeared much brighter than the full moon, but since it's 4 times farther away from Earth than the Sun, it wouldn't have turned night into day. However, it would have been visible in the daytime sky. Going back to Albireo, a small telescope at 30 power will show both stars. What's striking about the two is that they're different colors. One is yellow and the other is blue. They orbit around each other and take about 75,000 to 100,000 years to make one orbit. As it turns out, the broader yellow star is also a double, but those stars are too close together to be seen separately, so there are actually 3 stars in this system. Star colors are generally faint. They range along the color spectrum from red to blue, but when stars of different colors are viewed near each other, our eyes tend to exaggerate the colors and make the difference much more apparent. Albireo is an excellent example of this. Why do stars have different colors, and what does a color mean? A star's color tells us what its temperature is, and it's also a hint about its age. Really hot stars emit mostly high energy wavelengths of light. That corresponds to the short wavelengths of the spectrum, which is blue. The upper layer of a hot star has a temperature around 45,000 degrees Fahrenheit, which is 25,000 degrees Celsius. The coolest stars produce lower energy wavelengths. Those are the long wavelengths of red. They have a temperature around 5,400 degrees Fahrenheit, or 3,000 degrees Celsius. Our Sun, by comparison, is an average yellowish star. Its temperature is about 10,000 degrees Fahrenheit, or 6,000 degrees Celsius. But there's more to the spectrum than just the rainbow of colors we see. Our eyes have evolved to perceive the visible wavelengths of light, the color spectrum, because that's what the Sun produces the most of. Anything that's cooler than the red stars gives off very long wavelengths of infrared and lower radiation. We feel infrared as heat, but our eyes can't see it. Likewise, objects hotter than the blue stars produce very short wavelengths of ultraviolet and higher radiation. We can't see ultraviolet either, but it causes sunburn if we're not careful. Our Sun produces more light than what meets the eye. In addition to temperature, a star's color indicates its age. Stars that formed relatively recently, say a mere 100 million years or so, have a lot of hydrogen to fuse into helium. That produces a lot of energy, and those stars appear bluish. Ancient stars have used up most of their hydrogen and produce less energy. They're billions of years old and look reddish. Meanwhile, our Sun is just middle-aged at around 5 billion years. Speaking of our Sun, it'll rise at 6:15 in the morning on the 10th. By the end of the week, on May 16th, sunrise is at 6:09. Thank you for visiting, and keep looking up.